All right, so that is going to be your point estimate for the true proportion of red beads. I want to identify the population, the parameter, the sample, and the statistic. What is the population in this example? All the beads. Population is going to be all the beads in the jar. So what is our parameter here? Yes, the proportion of red beads, the true proportion. We're going to call that P. True proportion of red beads. What is our sample then? Yes, 20 what? 20 beads from this jar, yes. And what is the statistic? P hat, which is whatever you calculated. So whatever you had right here, this is your P hat. You need to put this on the line. When I was playing around with these earlier, 7 out of my 20 beads were red, which gave me a statistic of 0.35 when I played around with it beforehand. So that's just an example of a statistic here. You would put your number. I'm going to put mine here. And what does P hat represent again? The sample proportion. We're going to call this a point estimate, but yes, it is my sample proportion. So between you and your partner, and this is where the opportunity for extra credit comes in, you are going to change your point estimate into an interval of values by adding and subtracting some value from your point estimate. The number you add and subtract is called your margin of error. It has to be the same thing that you add as that you subtract. So we're going to make an interval that goes on either side of your point estimate. Your goal in doing this is to capture whatever the true proportion is in your interval. So you want your interval to be large enough, this is your margin of error, you want your interval to be large enough to capture whatever you think the true proportion probably is. We have an estimate, a sample proportion for what that is. You can choose any amount to add and subtract, but remember, the smallest interval that captures the truth is going to be our winner. What margin of error do you want to use and why? So I want you guys to answer number 3, number 4, and number 5 with your partner. So what margin of error do you want to use? What are you going to add and subtract to your point estimate? And then I want you to actually do that to create your interval. And then decide how confident you think you are in your estimate. While you guys are doing this, I'm going to come around and collect your samples since everybody has their point estimate calculated already. Huh?
I'll say like it's a lot more by like a 10.
So I would be adding some this. Okay. So decide on some value that you want to add and subtract to that. It makes it easier than working with the fraction.
No, I was imagining that it would be this, and I was going to say 3 because of that
So you're gonna add and subtract something to your point estimate. We want to make sure, if you think that the triple portion is quite a bit lower than that, you want to make sure that whatever you add and subtract to both sides, you can show that lower side. So for example, if you think the triple portion here is actually 30%, or subtract this, make sure that the roll right down to 30%. Yeah, so you'd add and subtract your so your interval would go from 0.3 to what? 100, right? To 100. So if you think the true portion is that small, you can add and subtract that to both sides.
Everything off of that.
Your true portion is that. Now, real world context of this makes sense.
I'm a left fielder, but okay.
You're gonna decide what your margin of error is there.
I've been playing softball since 8th grade, but I never played baseball since 65%. The only time I played was my old school. You probably don't even know. It's in Brownsburg. I feel like it's.
So you play now, right? You play count. You're not. It's not much time.
I'm working full time.
Money.
It's so good having money.
You're working full-time, full-time? Oh my goodness. That's a lot, school and full-time work is a lot.
I know, so I have to get after sports because I technically I used to do like 6 sports or whatever, but it doesn't happen.
Can't do that much,
Mm-mm.
yeah. Does not work.
Texas.
All right, so I'm curious to hear, what were some of the margins of error that were selected? What did you guys go with? 0.10. So we do plus or minus 0.10. Why did you select 10%?
Because it's, well, we got 9 out of 20 and we added 3 to that, and then 11 out of 20 was 0.55, so we subtracted.
Okay, I like it, yeah.
Yeah.
What did you guys go with for your margin of error? Same thing? Did you guys go with 10% or something different? 0.05. Keeping an eye on that extra credit there because we want the smallest interval that captures the true percentage. What did you guys go with? 0.05. Or sorry, I wrote 0.5 up there. I meant to write 0.05. So 0.05, 0.05. What did you guys go with? 0.05? 0.045. Even tighter margin. What did you guys do? 0.2. And what did you guys go with? 0.05. Okay. So I want to get these intervals. So with my example, I thought that 0.3, or I had a point estimate of 0.35 when I did mine because I got 7 out of 20. So my interval was 0.35. I went with a 10% margin of error when I did this as well, so plus or minus 10%. So I had from 0.25 to 0.45. You guys understand how to do your margins? Okay, because I'm going to write them down. We're going to figure out who got the closest. All right, so I'm going to start over here. What was your margin? From what to what?
0.35 to 0.55.
You said 0.35 to 0.55?
Yeah.
Oh, I meant to do a bracket there. Parker and Annalise, what do you guys have?
0.4 to 0.6.
You said 0.4 to 0.6? What do you guys have? 0.5 to 0.6. Grayson, what do you guys have? 0.35 to 0.45. What do you guys have? 0.45 0.55. Aiden.
So
0.405
0.495.
to 0.495. What do you guys have?
0.45 to 0.85.
0.45 to 0.85. And last group, what do you guys have? 0.4 to 0.5. How confident are you? How confident do you feel that your interval captures the true proportion? How confident do you feel that your interval captures the true proportion? About how much? 80%. About 80%. Anybody feel more confident than that? So somewhere around 80%? No, not 80% confident. So you have to decide how confident you feel. So just as an example. And we'll talk about how to actually come up with this value later on. There will be a way that we can say, I am this % confident that we have captured the true proportion. But 80%, we're just kind of ballparking, just kind of a gut check feel right now. So the way we would state that then, and this is going to have to be language that we remember the pattern of. This is going to be used over and over and over and over and over and over again. We're going to say, we are, in this case, we said 80%. 80% confident that the interval from, and then you need your interval. So I'm going to use the one that I came up with. Mine was from 0.25 to 0.45. That the interval from, in my case, that would be 0.25 to 0.45. Captures the true proportion of red beads in the jar. We are 80% confident that the interval from, again, I'm using my interval from up above, 0.25 to 0.45, captures the true proportion of, and then I've added my context here. Red beads in the jar is our context. That's what we're trying to find the true proportion of. All right. Time to find our winner. So I'm going to come over here and cross out anybody that does not actually contain the true proportion. This one does not. This one does not. So those two do not. 0.35 to 0.45 was mine, or sorry, 0.25 to 0.45 was mine, and mine did not include it. Okay, so now we need the tightest interval. This is our winner. The tightest interval. The true proportion of red beads in that jar was 0.482, 48.2% of those red beads. Now, obviously, we just took a point estimate. Did all of our estimates actually contain the true proportion? Just about all except for how many? So 1, 2, 3, 4, 5, 6, 7, 8. If you include mine, we had 9. So 6 out of 9. What's 6 out of 9? 60, so we should have come in more like, we're more like 67% confident here that we are containing the true proportion. One of the groups, fictitious group, had an interval of 0.27 to 0.33. What was their point estimate? What was their proportion of red beads that they got? And what was their margin of error? How can we figure this out? If all we know is their interval, how can we figure out what their point estimate was? Mm-hmm. So for the point estimate, we're going to add those two and divide by 2. We're going to average those because remember, we're adding and subtracting the same thing to both sides. So I want to find what's in the exact middle here. 0.27 plus 0.33. We're going to cut that in half then. Go ahead and pop that into your calculator and tell me what you get. .3. So they got 30%. For the interval A, B, if I want the point estimate, I'm going to add A and B together and cut it in half. Then our margin of error. How would I figure out what we were adding and subtracting to both sides?
Subtract 0.3 from 0.33 and subtract 2.27 from 0.3.
Mm-hmm. We can do it like that. We could also, if you just want to work with the numbers from the interval, for the margin of error, we can take the larger one, subtract the smaller one, and cut it in half. That's what was added and subtracted to both sides. This one happened to be a very easy computation to just look at the difference between the point estimate and the upper and lower bound on our interval. But we end up with 0.03 here. So margin of error, we're going to take the larger end of our interval minus the smaller end and cut it in half. That's what you added and subtracted to both sides. If one of our groups had claimed that the true proportion of red beads was 0.25, does your interval support or deny that claim? Look at your interval. If somebody claimed that the true proportion was 0.25, does your interval support that? Or does it negate it? So write that down on number 7. For mine, what was my interval? .35 was my point estimate. What was my interval? 0.25 to 0.45. So for mine, did it support or deny this claim? Mine supported it. Did any of our other intervals support that? No. Nobody else's interval included a value of 0.25. So let me get my answer for that one up there. My confidence interval contained 0.25. If yours did not contain 0.25, then you would say, no, my confidence interval did not contain 0.25. That confidence interval is supposed to contain all the plausible values for the true proportion. Let's get our big ideas. A point estimate is a statistic that provides a reasonable estimate about the population parameter. So we can have point estimates for our parameter p, that would be p hat. We can have point estimates for the mean, mu, that would be x bar. Today in our example, we did point estimates for p, but we could also do point estimates for the mean. For our interval from A to B, we can work backwards and figure out both what the point estimate is and what the margin of error is. Then we would say we are blank percent confident that the interval from, and then we're going to fill these in with values, A to B, captures the true, and then whatever the parameter is in context that we're looking at here. And our confidence intervals contain all plausible values. Let me write down who our winners were so I don't forget. Once you get these things copied down, which I know we're still not there yet, I want you to try the check your understanding down below. I want you to interpret the confidence interval using that sentence frame. I want you to calculate the point estimate and the margin of error. I want you to try to answer part C. What kind of decisions could we make from this confidence interval that we have? Gotten everything copied down. I want you to answer the questions down below. So using the sentence frame, we are blank percent confident. I want you to interpret the confidence interval that was given. using that confidence interval, I want you to calculate what the point estimate was, as well as what the margin of error is. That would be part B. And then part C, what kinds of decisions can we make based on this? And we make the decisions they're suggesting in part C. How would we interpret the confidence interval? We need to start off with what couple of words? We are 95% confident that what? That absolutely, yes. We are 95% confident that the interval from 0.352 to 0.548 captures the true proportion of adults who pay for subscriptions they do not use. What was the point estimate? 0.45. We take 0.352 plus 0.548, divide it by 2, you get 0.45. What was the margin of error? 0.098. Yes, there's my work for those. Based on this survey and the confidence interval that was generated, do we have evidence that supports the reporter's claim that a majority of adults continue to pay for monthly subscriptions they do not use? What would a majority mean? More than 50%. Do we have sufficient evidence in our confidence interval to state that a majority, that more than 50% of adults have subscriptions that they do not use? Do we have numbers over 50% in our interval? Do we have numbers under 50% in our interval? So looking at our interval, can we confidently state that yes, it has to be more than 50%? No, because we've got stuff on both sides of it here. I would need an interval that contained things that were only bigger than 50% if I were going to state confidently, yes, we have evidence to say that a majority. It could be a majority. Those are values that are contained in my confidence interval, but it can also be as low as, what, 35%. Would anybody in here count 35% as a majority? No. So we do not have evidence because our interval contains numbers that are both above and below. First homework, 8.1, is due on Thursday this week. Again, this is a very, very, very short unit with our test being next Friday. We're going to finish up 8.1 tomorrow. And then on Thursday, when your 8.1 homework is due, that is when I will give you your 8.2 homework. And we'll have 2 days for that. 8.3 is a very short, just 1 day section, and then we'll start reviewing.